right, here comes number 4. You know what I said in the previous video? That this one we do practice number 4 and 5. Let's just do them separately. Let's do number 4 only here in this video. I think it would get a bit long. Number 5 is a bit of a long problem. Okay, so number 4, we're going to see something a little different. Again, says the average number of minutes spent on a particular tablet app is 8.2 minutes. So you probably have speculated that any kind of an app you download communicates with the people who created the app, and they know how much people are using their apps, and they can find data like this. So um, the average use is 8.2 minutes. The standard deviation is 1 minute. A sample of 60 app use times are randomly selected. All right, well, before we get to part A, let's just go ahead and fill these things in. The average is our mu, right, 8.2. The standard deviation is 1. And a sample of 60, there's our n. Okay, so we got this going in. Now, part A says, find the 80th percentile for the sample mean time. Hey, we've got a percentile question. And if you remember from chapter 6, a percentile, if they give you the percent or percentile, that's what normally is the final answer. So we're going to be working backwards here to find x bar. Okay, so like x bar, we don't know. So we're gonna set it up like this. We're gonna say, hey, they're telling me the final answer, the 80th percentile, 0.80. And that's my formula, right? So work backwards in the table to find z. And once we have z, just kind of give you an idea of how this problem's going to play out. Once we know what z is by working backwards in our table from 0.80, then we're going to use, hopefully this all fits on my screen, then we're going to go with our formula, z equals x bar minus mu over sigma over the square root of n. Okay, so at that point, once we know z, we can plug in z, we know mu, we know sigma, we know n, and we can solve for x bar, which is going to answer. We want the 80th percentile for the mean time, x bar. All right. So first step, use the fact that it's 0.80 to work backwards in the table. So I'll let you guys do that. We did it a little bit right back in chapter 6. So probably when you're looking in your table, and you're going to be looking in the middle of the table to find 0.80, you're probably not going to find 0.80 exactly. We're just going to find the closest thing to it. Okay, and it takes a little time, but maybe at least we can know, should we be looking at the negative z-scores, or should we be looking at the positive z-scores? Right, so it'd be nice if we were in class and I'd say, which one? And maybe lots of people would know. If we're looking at the 80th percentile, we need to look at the positive z-scores. Why is that? Because right there down the middle at the 0, that's the 50th percentile. That cuts off 50% of the data. So if we're talking about 80% of the data, then we're definitely up here somewhere, as opposed to being down there, right below 50%. Okay, so 80th percentile, that's above 50%. We're going to start looking in here, and we can see something close already. I'm going to kind of give you guys a chance. You might want to pause the video here, look through the table, and find the closest thing you can to 0.80. And I'll do the same. Okay, so I got it. If you're still looking, pause the video. I found that the closest thing that I found was 0.7995. And that came from z equals 0.84. Just kind of my note. And you're doing a problem on your own. You don't need to note this, but just for the lecture, this is the closest thing that I could find in the middle of the table to my percentile, and it matched up with z equals 0.84. Okay, so this is great. We have our z-score. We have all these other values. Let's go ahead and plug everything in. And we'll solve this for x bar. All right, so I recommend, this square root is not very pretty. I recommend just taking that whole thing and multiplying it over this way. Something like that. So that entire denominator gets over there. Then all we got to do is add the 8.2. And at this point, let's just type it all in and round. And I'll do that with you guys. 0.84 divided by the square root of 60 plus 8.2. I got this, I think it said round to 1 decimal place back in the problem. I got 8.3 when you round to 1 decimal place. Okay. Well, I gave it away, but what are the units? What are the units on that 8.3? And they're the same as the units for mu, minutes. So the average is 8.2 minutes. The 80th percentile is only up 0.1 minutes. Wow. Well, we took a sample size of 60. I mean, that's a big sample size. So it's really squished into the middle. Okay. I won't do the picture. You get the idea. All right, let's check out part B. I'm going to cover this up just for the moment while we read it. Find the probability that the sample mean is between 8.0 and 8.5 minutes. Okay, so now this one we are working forwards, but now a little bit different. Now our sample mean is going to be between these two numbers. So I'm going to start off just by writing this, and actually it said 8.0. I'm going to keep that. So our sample mean, x bar, falls between 8.0 and 8.5. What are the chances that that happens? Okay. We've had these like between sort of problems before, and it's going to play out in a similar way. Let's take a look. I need to find the z-score that goes with x bar equaling 8.0, and I need to find the z-score for x bar equaling 8.5, and then we can find the probability between using the table. So here's what I'm going to do, and I'm just going to show you all this. We're going to set x bar equal to the lower one first. And we've got all the same values that they gave us back in the beginning, right? The mu, 8.2, standard deviation is 1, sample size is 60. So we're putting in 8.0 for x bar and calculating that. We got the z-score to be negative 1.55. Okay, keep that in mind. Now, let's say x bar equals the bigger one, and we'll find that z-score. The z-score that goes with 8.5, well, okay, we've done this several times now. We're putting it in. Make sure, please calculate these along with me. Make sure you get 2.32 as that z-score. Now that we have these two z-scores, and we're thinking that it's between, we're going to find the probability that capital Z is between the negative 1.55 and the 2.32. X is between these. That means Z is between these. So there you go. Now, how do you actually go about doing this when you've got the 2? Well, we saw it back in the previous chapter. If z is stuck between, I think we even saw it in chapter 5. If z is stuck between, you take the probability that z is less than the bigger one, and you subtract the probability that z, oh, I didn't even write it all out. I think I was worried about space. Z less than negative 1.55. Hopefully that's all on the screen. It is, barely. The bigger one minus the lesser one, and they're both less thans. And when you subtract that, you know, if I was to do the drawing, then that would just be the area between the two, right? We've explained that before. Okay. Now we're just kind of remembering, the execution, I guess. Okay, well, let's look these up. And I left this blank for us. Let's look this one up in the table. Let's see, 2.32, 2.32, 0.9898. Negative 1.55, got to flip it over. Negative 1.55, 0.0606. A lot of repetition in both those, interesting. And all we got to do now is subtract, and there's our answer, 0.9292. The probability that x lies between 8.0 minutes and 8.5 minutes. Quite high, almost 93%, almost. We could draw this graph. Hey, why not? Why not? I didn't draw it for part A. What's happening here? So we've got this steep, very steep normal distribution, right? A sample size of 60. Okay. The average is 8.2 there in the middle. So we want to know the chances of being between 8.0 and 8.5. Something like that. Well, we haven't strayed very far, it doesn't seem, but because it's pushed together so much, that right there ends up being 0.9292. 92.92% of the data falls between 8.0 and 8.5. Just this tiny little bit out here, a little bit more out there to make up the rest of it. Okay, I'm glad we only did number 4 here. Practice number 5 is next.